Good morning, students. Welcome back to the mathematics class. We shall start with the worked examples. Okay, so the first one, yesterday we have solved find the value of n, right? The next example is example 13. So what does example 13 tell us? Find r. Okay, if 5 into 4pr, which is equal to 6 into 5p r minus 1. So if this is the mathematical equation, so they are asking us to find r. Okay, so we know how to solve it, right? So what is the formula of npr? Npr formula is n factorial by n minus r factorial. Okay, students. So using this formula, so let us simplify the 13th question. Right. So what is our 13th equation given? 5 into 4pr, which is equal to 6 into 5pr minus 1. Is that clear, students? So now just let us apply the formula. So let me write here as a reminder. So which formula is it for NPR? Okay, so 5 into 4PR. So in place of n it is 4. So it means 4 factorial by 4 minus r factorial. Yes, students. So which is equal to 6 into 5 p r minus 1. So 5 factorial by n minus. So what is n here? 5. N minus of r. So in place of r, in this particular problem, we have r minus 1. Right? So whenever there is minus, be careful, students. Add a bracket. It will be easier. So factorial. Is that clear now? So now look here. This is our 4 factorial, right? So 4 factorial is nothing but 4 into 3 into 2 into 1, right, students? So previous to the 4 factorial, there is a 5. This is nothing but 5 into 4 factorial. Right. So 5 into 4 into 3 into 1. What is it, students? 5 factorial. Right. So can I write 5 into 4 factorial as 5 factorial divided by 4 minus r factorial, which is equal to 6 into 5 factorial. You might have understood why sir has written 5 into 4 factorial as 5 factorial, because on the RHS side I have my 5 factorial. So left hand side, right hand side, we have similar terms. If we have similar terms, it will be easier to cancel them and simplify, right? So whole divided by 5, negative multiply inside, minus r, negative into negative, plus 1 factorial. Is that clear, students? 5 factorial get cancels, right? So we will be left with 1 by 4 minus r factorial, which is equal to 6 divided by 5 plus 1 is 6. 5 plus 1 is 6. 6 minus r whole factorial. Yes, students. So now just let me cross multiply. So, okay. So 6 minus r whole factorial is equal to 6 into 4 minus r whole factorial. Right, students? So now using the definition of factorial notation, we shall simplify these terms. Okay. So what does, I'll keep reminding you, okay, because here students forget it. So what is 5 factorial? 5 factorial is nothing but 5, 4, 3, 2, 1. Or 3 factorial is nothing but 3 into 2 into 1. So when you open this factorial notation, 3 factorial is nothing but 3, 2, 1. So you can see it is being reduced by 1. Is that clear? So I'll apply factorial notation onto this 6 minus r, right? And there is a 4 minus r factorial. Yes, students. So now can I write this as 6 minus r factorial as it is? Yes, students. So now can I write this as 6, right? 6 into, okay. So let me simplify this. I have told you, right? Apply definition. So 6 minus r, open this factorial. Now reduce it by 1, 6 minus r minus 1, right? So 6 minus 1 is nothing but 5. So can I write this as 5 minus r? Yes, students. So now again in the next term, it will be reduced by 1, right? So 5 minus 1, what is 5 minus 1? 4. So I'll stop here because on right hand side, I have 4 minus r factorial. Yes, students. Okay. So now if you observe 4 minus r factorial, 4 minus r factorial get cancels. Okay. So now cancelling that, I'll write here above. We don't have space. Right. So now what we are left with, 6 minus r, 5 minus r is equal to 6. These term get cancels, right? This term get cancels. So 6 minus r into 5 minus r equal to 6. Now just multiply these terms. 6 into 5, 30. 6 into minus r, minus 6r. Minus r into 5, minus 5r. Right? Minus r into minus r plus r square is equal to 6. Okay. So now r square minus 6 minus 5r minus 11r, right? So plus 30 here. So the 6 on the right hand side shift to the left hand side, minus 6. R square minus 11r, 30 minus 6. What's the answer? 24. So now this is nothing but our quadratic equation. Right, students? So now we shall simplify the quadratic equation. Okay. So now how will you split this one? So now what's the coefficient of r square? 1. So 1 into 24 is 24. So now you have to take two factors in such a way that when you multiply you should get 24 plus 24, and when you add or subtract you should get 11. So there are only two numbers possible, that is 8 and 3, right? So 8 into 3, 24, right? Plus 8 plus 3 is 11, but you should get minus. So minus 8 minus 3, right? So r square minus 8r, right, minus 3r plus 24 equal to 0. Okay, students. So now among these two, can I take r common? So r minus 8. So in these two, minus 3 common, r minus 8 equal to 0. Right? Now you can see r minus 8 is common, r minus 8, r minus 3 equal to 0. Okay, students. So now what is your r value? So your r value is r minus 8 equal to 0, or r equal to r minus 3 equal to 0 means it's 3 only. So hence r is equal to 8 or r is equal to 3. Is that clear? So what is the value of r? Either 8 or 3. Now we have to check with respect to the question which to be considered. Okay. So which to be considered is also important. So among this, just consider 4pr. Right? 4pr. If you take r is 8, if you take r is 8, so what does it indicate? You are arranging 8 objects out of 4. So it's totally meaningless, right? You have only 4 objects, right? So this representation in general is npr. So here n objects, the total objects are n here. Here the total objects are 4. So you are having only 4 objects with you. How can you arrange it among 8 objects? Or if you are having 4 books with you, how can you give it to 8 people? Right? So r equal to 8 is nothing but wrong. So 3 is possible. R equal to 8 is not possible. 3 is possible. Now look here. There are 4 objects with you. Right? So you can give it to 3 persons. This makes sense. But when you take r is equal to 8, it's totally meaningless. So this is to be ignored. So r is equal to 3 is the correct answer for this problem. Is that clear? Okay, so now we shall start with the example 14. So yesterday what we have discussed? We have discussed regarding distinct objects, right? Not distinct objects. Is that clear? So not distinct objects means all the objects. So distinct objects and not distinct objects. Okay. So if P are of one kind, if there are n objects, and P are of one kind, so what's the formula? N factorial by P factorial. Okay. So here this is used when objects, if we have some objects similar. Okay. So if we are having distinct objects, if we are having different distinct objects, all are different, means what's the formula to be used? NPR. NPR is equal to n factorial by n minus r factorial. But if you find some non-distinct objects, right, some are similar, so similar means use this formula, right? So now on every occasion you have to check whether they are distinct objects, whether they are different objects, or not different means similar objects. Okay. So now reading example 14, find the number of different 8-letter arrangements. Find the number of different 8-letter arrangements that can be made from the letters of the word. So you have to make a 8-letter arrangements from which word, from which letters? The letters of the word daughter. So that, what is the first condition? All vowels occur together, means all the vowels come together, right? All vowels. So you have all vowels do not occur together, right? So what they have done? They have given a word daughter. Okay, so now if you count, how many are these? These are nothing but 8 letters. And can I say all the 8 letters are different here? So you can see no letter is repeated more than once. These appearing one, A is also appearing one time, U, G, H, T, E, R. Is that right, students? All are different, means all are distinct objects. So which formula I have to use? I have to use the concept of NPR. Is that clear? But with some conditions. So what is that condition they have given? We shall see. Okay. So now what is the question? The question is find the number of different 8-letter arrangements. So how many different 8-letter arrangements you can make from the letters of the word daughter. So using these letters only you have to make. Okay. So that, what is the first condition? All vowels should occur together, means all the vowels should be together only. Okay, this is a very important problem, and we shall approach, there is a way to approach to this problem, right? So we shall solve in that manner. So whenever you come across, there are some problems, vowels are occurring together, right? Or 4 friends are together, or there are I letter or A letter are always together. So we come across there are some problems of these kind. So whenever we come across such types, so we need to follow a particular method. Okay, so let us analyze it. So can I say there are 8 different letters, right? There are 8 different letters in the word daughter. Yes, students, there are 8 different letters in the word daughter, right? Among of which, so what are vowels? So let me remind you. So vowels, you have been studying it since long back. So what are vowels? Vowels are nothing but letters comprising of A, E, I, O, U, right? So these 5 letters are grouped into, are called as vowels. Okay, the rest are consonants. Is that clear, students? So now let me check, are there any vowels in the given word daughter, right? So is A present, students? Yes. Is E present, students? Yes, it's over here, right? Is I present? I is not present, right? Is O present? O is also not present. Is U present? Yes. Is that clear? So these are the 3 vowels. present in the word daughter, of which there are three vowels. Okay, so and three vowels, namely A, E, U. So let's start the solving of first one. So now look here, you need a good imagination over here. All vowels occur together means what they are saying, these vowels occur together means they are together always. Okay, so they are together always. So for that reason, I will put them in a box or tie them up because they have to be together, right? So they shouldn't move. They are intact. They all the three. You can say there are three friends also vowels A, E, U. They are three vowels and they should occur together means bind them together. So this is nothing but so vowels always occur together. So take all the vowels and put it in a box, right? So this is nothing but one object, right? So in this what are the numbers here, what are the letters here? A, E, U, right? So for time being let us consider this as one complete object, right? So from the word daughter, since the condition is all the verbs should be together, they should always be together, right? So for that, what I have done, I have taken A from here, U from here, E from here, and put it in a single box. I have put them into a single box. Is that clear? So now, how many letters are remaining now? So there are five letters, right? Now we have. So one condition is over, right? So the condition is we have to arrange such that all the vowels are together. So I have done it. I have put it in one box. Now these, right? So these are five different letters. So how many we are having? Five. Is that clear? So D, G, H, T, R. How many? Five. So what we have done, we have taken A, U, E vowels together and put it in a single box because they have to occur together. So that single object or that single box with the remaining five boxes or objects. So total how many are there now? How many objects do we have now? Six objects, right? So six objects we have. So how do we arrange six objects, right? So we have six objects. How do we arrange them among themselves? So 6 right? So we have six objects, right? So you can shift this here, right? Again there will be five. You can, so how many ways you can arrange these six boxes, right? You can move this six boxes out of six ways, right? So this is nothing but 6 factorial. Is that clear? NPN formula, I've written it directly. NPN, what is that? NPN is equal to n factorial. We have discussed in the special cases, right? Is that clear? So now this is over. But there is in this box, we have AUE also. Those letters can be arranged among themselves also. AEU, AUE, EUA, EAU. So in such way we can arrange them, right? So how many are there here? Three, right? So in this box, how many we have? Three. So we are arranging them among three places. So it's nothing but 3p3, 3 factorial, right, students? So what we have done? So for a time being, we have considered AEU as a single object, right? So single object, and how among eight, three are into this box. So how many are left now? Five objects, right? So these five objects with this one object accounts for 6 objects. So how will you arrange these 6 boxes? 6 ways. Right, students? So the arrangement can be done in this box also, right? There is no rule that A must be first, E must be second, and U must be third. They can arrange among themselves also, right? So that is our 3. And after this, and still the work is into progress. So I have to arrange these also 3 ways. So hence the total number of ways is equal to, by multiplication principle, 6 factorial into 3 factorial. Okay, so by simplifying we'll get an answer. Okay, we shall see that. So the total number of ways of arranging vowels together is 6p6 into 3p3, or 6 factorial into 3 factorial. Is that clear, students? Or else we can understand by a simple example also. I believe everyone have been to a picnic or an excursion, right? So the same thing, don't worry. Okay. So now look here. So let me think. These are 6 different letters, right? So I say there are 6 different students, right? So there are 6 different, sorry, 8 different students, right? So they are going for a picnic, okay, by train. Is that clear? Okay. So trains have bogies, right? Okay, so now look here. So first, what is the first condition? A, E, U vowel. So these vowels should occur together. Means these A, E, U have to be put into one bogie only, right? This is our one bogie. Okay, so in that we have A, E, U. Is that clear? So how many still students are left? So if A is gone, U is gone, E is gone into one bogie. So how many we are considering this as one single object, right? So how many still there are students? D, G, H, T, R. So these are nothing but 5, right? So now these bogies can be arranged one after the other, right? So this can be first bogie, or this can be this bogie. So the arrangement is happening among themselves also, right? So there are 6 bogies, right? So 6 bogies can be arranged among 6 ways, 6 factorial, right? So A, E, U, these are vowels. Okay, so these students I have put it in here, A, E, U. So will the students sit simply? They will arrange among themselves also, right? So there are 3 different objects. They can be arranged in 3p3. So hence it is 6 factorial into 3 factorial. Now just simplify, what will be the answer? 6, 5, 4, 3, 2 into 1, right? Into 3 factorial. 3 into 2 into 1. Okay, so this is how much? 3 into 2 into 1. This is 6. Okay, students. So now this is 2, 6, right? So this 5 fours are 20. 6 into 5 fours are 20 into 3 twos are 6, right? So 6 into 120 into 6. So simplify and see what will be the answer. The answer will be 4320. Okay, students, the answer will be 432 students. So there are how many arrangements? A 4320. I'll write here above. It's not visible. Total number of ways in which vowels occur together. Is 6 factorial into 3 factorial, and it's nothing but 6, 5, 4, 3 into 2 into 1. Just multiply all these students. So what was the answer? The answer is 4320. Okay, just multiply. Now second one. Okay, second one is nothing but contrast to the first one. See, all vowels occur together. And the second one is all vowels do not occur together. Right? So they are saying they shouldn't never occur together. Right? So for that, we will go with an understanding. So it's a logic way. Okay. So now forget about the conditions given. So either vowel occur together or do not occur together. Forget it. So now just concentrate on the word daughter and how it can be arranged, right? So for time being, forget both the conditions. So what is that question? Find the number of different 8-letter arrangements that can be made. We have to make a 8-letter arrangements that can be made from the letters of the word daughter. And here daughter, all are distinct objects. So which formula? NPR formula. And it has to be made the 8-letter arrangements. Yes, students. So eight letters are present in the word daughter, right? So it has to be arranged among 8, right? So this is nothing but our total arrangements without any condition. Total arrangements without any condition. So what is 8p8? So when you solve, if you simplify also, you'll get correct only. We have seen it in the special cases derivation. Okay, so this is NPR, n factorial by n minus r. 8 minus 8 whole factorial. 8 factorial by 0 factorial equal to 8 factorial. Okay, so they can be arranged among 8 factorial ways. This is regarding any condition or without no condition, right? So this is 8 factorial. But now what they are asking, all vowels do not occur together. First one is all vowels occur together. So occur together, we have solved now. This is nothing but vowels occur together, right? So in the total arrangements, just minus the vowels occurring together, remove vowels occurring together. So what we will get? Vowels do not occur together. Right, students? So we will get vowels do not occur together. So what is that? Total arrangements is 8 factorial minus vowels occur together. So vowels occur together. What's the answer? 4320. Yes, students. So now 8 factorial. 8 factorial is nothing but 8 into 7 into 6, 5, 4, 3, 2 into 1 minus 4320, right? So which is equal to just multiply and see what will be the answer. So 8 factorial, when you multiply this, you will get 40,320. It will take time, that's why I'm writing it directly. Okay, so you can multiply this. So 5 factorial is nothing but 5, 4, 3, 2, 1 is nothing but 120. 120 into 6 is nothing but 720. So 720 into 7, 7 into 8. So just multiply, you will get this one. Right. So now 40,320 minus 4320. So 0. Right. So 3, if you reduce, it will be 0 only. So it's 36,000. Right. So vowels do not occur together. How many are there? 36,000. Okay. So is that clear? So now example 15. Okay, so there are still more problems based on the idea of vowels occur together and vowels do not occur together. You have to go it in the same manner only. Okay, so now 15th one. So 15th one is, in how many ways can 4 red, 3 yellow and 2 green discs be arranged in a row if the discs of the same color, if the disc, these are discs, they are nothing but kind of a circular rings, right? So if the discs of the same color are indistinguishable. So what they are given? 4 red, right? So again what they have given? 3 yellow, right? So they have given 3 green. So in how many ways we can arrange it in a row? If the discs of the same color, see, discs of the same color are indistinguishable. So distinguishable means different, or you can distinct them, they are different, right? So indistinguishable means they are same. So this 4 discs are of the same color only, right? So yellow, these 3, green 2. So this is nothing but, in this how many total objects are there? Total, if you see, there are 4 red, right, plus 3 yellow, plus 2 green. So how many there are? 7, yeah, correct, 9 discs. Right. So now you can see yesterday's concepts. All the objects are not distinct. Here they are repeating. Right. Here they are occurring more than once. So totally there are 9 discs, of which red disc is of one kind. Right. So how many red discs are there? 4. Yellow discs are of one kind, right? So how many they are? 3. Green discs are of one kind, right? So how many they are? 2. So what is the formula for such type of questions? Yesterday only we have discussed n factorial by p factorial if p is of one kind, but here we are having more objects which are similar kind. So for that general we have written n factorial by p1 factorial, p2 factorial, so on up to pk factorial, right? So now what will be the total number of arrangements here? So you have to quickly identify whether it is a distinct object or a non-distinct object. Okay, students. So in the word daughter, all the letters were different. All the letters were different. So I can say they were distinct objects. So hence I used, what did I use over there? NPR concept. Yes, students. But here in this example 15, you can see red is occurring how many times? 4 times. Okay, so there is a group going on, one kind. Red is of one kind, yellow is of one kind, green discs is of one kind. Right? So in total there are 9 discs, but among them 4 is of red type, 3 is of yellow type, and 2 are of green type. Is that clear? So hence total number of ways in which we can arrange them is nothing but n factorial. N means total. So how many we have? 9 factorial divided by the divided out of one kind. Red is occurring 4 times, right? Yellow 3 and green 2. Is that clear, students? Okay, so this we shall simplify. 9 into 8, 7 into 9, 8, 7, 6, 5, 4 factorial. So this is our answer. Let me simplify. I've stopped till here 4 factorial because in the denominator we have 4 factorial, 3 factorial into 2 factorial. Yes, students. So 4 factorial get cancels. Right. So what we are left with? 9, 8, 7, 6, 5 whole divided by 3 factorial into 2 factorial. Right. 9, 8, 7, 6, 5 whole divided by, what is 3 factorial? 3 into 2 into 1. Yes, students. Into 2 factorial. 2 into 1. Right. So this is nothing but 3 2s are 6, 6 into 1, 6. So can I write this as just 6? And this 2 into 1 as 2 only. So this 6 get cancels, right? 2 1s are 2 4s are get cancels. 9 into 4 into 7 into 5. So just multiply the students, you will get the answer. 9 4s are 36. So 7 5s are 35. So 36 into 35, what will be the answer? So it's nothing but 1260. Just multiply and check, okay? Is that clear, students? Example 13, 14, 15, we have solved. So now moving on to the next question. So it's example 16. Okay. So I'll just recall what we have studied. So permutations when all the objects are distinct. Permutations when all the objects are distinct. So when all the objects are different, as in case of daughter we saw, right? So here all the letters occurring in the daughter are different. So for that, what kind of arrangement? NPR. Okay. So NPR, n factorial by n minus r factorial. Yes, students. So now when permutations, when all the objects are not distinct, so not distinct, we came across two formulas, right? So the two formulas were, so n factorial by p factorial if p objects are of one kind, and if there are more than one object which are of one kind, so it is nothing but p1 factorial. P1 is of one kind, p2 is of one kind, so on up to pk factorial. Keep reminding or keep recalling them so that it will be easier for you to apply the concept in the question. Okay. So now example 16. Example 16 is bit lengthier, very lengthier, so it will take time. So since we are about to start the doubt session, so we shall solve two problems, so few problems from the exercise. Okay, then tomorrow we shall solve worked example 16. So exercise 7.3. So what does it tell? First one, how many 3-digit numbers can be formed? 3-digit numbers can be formed by using the digits 1 to 9, right? If no digit is repeated, right? So they are asking us to form a 3-digit number, right? So they are asking us to form a 3-digit number formed by using the digits 1 from 1 to 9. Yes, students. Okay, so using these digits, we have to form a 3-digit number. You can either solve it by fundamental principle of counting, also you'll get the same answer, and if you solve it by the formula also you'll get the same answer. Don't worry, students. So what is the collection of objects given here? 1 2 3 4 5 6 7 8 9. right? So among this 9, using these 9 objects, I have to form a 3-digit numbers, and with the condition no digit is repeated, right? So here, let this be our units place, this is our tens place, hundreds place. So now tell me, to fill the units place, how many possibilities we have, or how many objects do we have? All are different. You can see all are different. No object is of one kind, or no number is repeating more than once, right? So all are different. These are distinct objects, right? So among these 9, how many do we have here to fill? I have 9 possible ways, right? Now no digit can be repeated, means among this 9, one has been inputted here. So it will be reduced now. So how many we are left with? 8, right? So tens place can be filled in how many ways? 8 ways. Okay, so the condition here is no digit is repeated, it shouldn't be repeated again, right? So let's suppose 2 has been inputted here. So how many we are left with? We are left with 7 digits. So hundreds place can be filled in how many ways? 7 ways, right? So hence total number of ways is equal to 9 into 8 into 7. 9 8s are 72 into 7, right, students? So 7 2s are 14, right? So 7 7s are 7 2s are 14. One carry, 7 7s are 49, 504. 504 is the number of words that you get. Okay, students. So now, if you want to solve using the formula also, you can solve it. Okay, so don't worry, it's also easier, right? Okay, so how many digits are given? 9 digits, right? And we have to form a 3-digit number. 3-digit number out of 9 digits. We have to arrange a 3-digit number, right? So it's nothing but to fill all are, and no digit is repeated, and all are distinct means NPR formula, right? So total how many we have? 9, and it has to be arranged among 3 boxes. 9p3, 9 factorial by 9 minus 3 whole factorial, right? 9 factorial by 6 factorial. This is 9 into 8 into 7 into 6 factorial whole divided by 6 factorial. 6 factorial get cancels. 9 into 8 into 7. So this will be again 504. Is that, students? So with the formula also we got the same answer, because the concept is same itself. So it doesn't matter. But in some cases we need, with the help of formula only, it will be more easier. So that's why we derived a formula for NPR. So NPR is used when there are distinct objects, different objects. Okay, and there is no repetition. They don't ask us to repeat the numbers or repeat the letters. Okay, so now if there are similar kind of objects given to us, means that formula to be used is n factorial by p1 factorial, p2 factorial, up to pk factorial. Okay, so today we have completed 4 problems, right? So tomorrow we shall continue with the example 16, and then the remaining 7.3 problems. And if you observe each and every worked example, okay, each and every worked example is similar to the problems in 7.3. Okay, so you can solve them very easily. Okay, if you understand all the worked examples, you can solve all the 7.3 problems very easily. Okay, thank you, students, and we shall start with the doubt session. Okay, example 14. Find the number of find the number of different find the number of different 8-letter arrangements. Find the number of different 8-letter arrangements that can be made from the letters of the word daughter. Letters of the word daughter, right? So that first one, all the vowels occur together. Okay, students. So now here, what is given? Find the number of different 8-letter arrangements that can be made from the letters of the word daughter. So whenever they give you a question from, okay, so now check whether all the objects or the letters in the given word are distinct or no, right? So here all the letters in the word daughter are distinct, right? So no letter is occurring more than once. Is that clear? That you understand first. Now let's go with the question. So what is that first one? All the vowels should occur together. Means they should always stay together, very close to each other, right? So among the, you have to arrange. The question is arrange in such a way that the vowels should occur together always, right? So what are the vowels present here? The vowels present here are A, U, E. Right. So these are the three vowels. You know, right? So vowels we have studied in the grammar classes of English. So those are nothing but A, E, I, O, U. But we have in the given letter daughter, what are the vowels? A, U, E. Okay. So these three letters have to be together always. They must be together always. So that's why I will put it in a single box itself. So this is nothing but one box itself, right? So now we need to arrange. So still we have to form a 8 letters, right? So out of daughter in daughter, how many letters are there? 8 letters. So in 8 letters, already 3 have been used here. Why? Because vowels should be together. Tie them up, okay? So tie them up and put them in one box itself. So among the 8 letters of the daughter, 3 are already inside because they must be together, right? They must be tied together. So this is nothing but one object, right? Or you can say 5. This is in one box you are putting it, right? So this is nothing but one object, right? So out of 8, 3 are used here. Still how many are left? 5, right? So these are nothing but 5 objects. These are nothing but 5 objects, right? So this one single object. So for time being, we are considering it like that, okay, in one object only. Why? Because they are saying vowels should be together. So make them sit together. Or else you can also even think like A, U, E are friends. So always friends will be together only in one bench. Is that right? Okay. So this is acting as one object. They are together, right? So one object, in that object already 3 letters are there, right? So how many are left? 5 objects. So total one object plus 5 object, 6 objects. Right, students? So how can you arrange these 6 objects, right? So these 6 objects can be rearranged in 6 possible ways, right? So 6p 6 ways. So 6p 6 is nothing but 6 factorial, right? So still our task is not complete. Why? Because in one box or in one bench, as I have told you, there are three friends A, U, E. They won't sit like that only. There will be arrangement among themselves also, right? A, U, E friends can also arrange them among themselves. So how many here letters are there? Three. So that three can be arranged in three different places, right? So it's nothing but 3 factorial. So our total number of ways will be 6 factorial. Still the process is not complete. 3 factorial. Right? So this is the answer. Okay, simplify this and write down. So now the next part. So next part is all the vowels do not occur together. So logically we try to solve this one. Okay. So vowels occur together. What is the ways? 6 factorial into 3 factorial. Right. So for that we shall understand one thing. Okay. So now I give you some numbers. Right. So I have give you some 10. So how many letters, how many numbers I have given you? 10 letters. Okay. So I am telling you bifurcate them in terms of even and odd. Okay. So let me say you only understand even numbers, right? But I am asking tell me the odd numbers, but you don't know what are odd numbers, right? So just an logical way of thinking. Okay, just an understanding. So in the 10, so here how many digits I have given? 10 digits, and I am asking you to pick. So I am asking you to pick among 10 digits, pick the odd one, pick the odd one. And you don't know what are odd digits, but you know even. So what are those? So among the 10 digits, remove even numbers, right? So you will get the odd numbers, right? So these are nothing but odd numbers only, right? So in the same way, so among the total arrangements, remove all the vowels occur together. So what you will get? All the vowels do not occur together. Okay. So first, second one. So total number of ways or number of ways vowels do not occur together is nothing but total arrangements minus vowels occur together, right? So for total arrangements, how many we have? 8 letters in the word daughter, right? So all are distinct. Which formula? NPR formula, right? So they have to be rearranged among themselves. So there are 8, they must be rearranged among themselves, so that it will be a 8 letter word. 8p8 minus vowels occur together. Just now we solved 6 factorial into 3 factorial. So what is 8p8? 8p8 is nothing but 8 factorial minus the 6 factorial into 3 factorial. Just simplify this, students. You will get the answer. Okay.
All possible, isn't it?